Thank you all so much for coming on the first day of class. I'm Christian Sandvig. I'm here to welcome you to the Year of Social Media Public Event Series. I'd like to introduce our speaker today, Eytan Adar. I'll give you more details about him, but first I need to make a couple of announcements. One is that fans of this series will be glad to know that next Wednesday, the 25th at 4 p.m., Bernardo Huberman will be here giving the Windsor Lecture, and his topic will be social media and attention, perhaps of interest to this group, and that'll be in the Library and Information Science building. Also, the next talk in this series will be in February. That will be Bill Dutton from Oxford University, and he'll be talking about what he calls the fifth estate and the role of blogs and social media in public accountability. But today, let me introduce to you Eytan Adar, Assistant Professor of Information and Computer Science at the University of Michigan. His research investigates temporal informatics, or the study of change of information and our consumption of it over time and at internet scale. His prior work includes text mining and log mining, visualization, social network analysis. He previously worked as a researcher at HP Labs' Information Dynamics Group and also at Xerox PARC. He received a PhD in computer science and engineering from the University of Washington, and he's a past winner of Best Paper Award at CHI and many other conferences. I actually forgot an announcement. Oh my gosh. Let me one more announcement, sorry. Let me announce that we are very grateful to Eytan Adar for waiting through this introduction, but also to the Coordinated Science Laboratory for co-sponsoring this event, which was also co-sponsored by the Illinois Informatics Institute and the College of Media. Okay, now without further ado, Eytan Adar.
It just died. Oh, can you hear me?
Yeah.
Great. Okay, so hi. Thank you all for coming. I understand it's your first day of class. We've been in for 2 weeks now, so it's a little foreign to me, but I appreciate it. I also understand that I have a really tough act to follow, that in past talks you've had stand-up comics and nudity. I'm afraid I don't have that much of that kind of stuff, but hopefully you'll still find it mostly interesting. So as Christian said, I am a professor at the School of Information and also Computer Science and Engineering at the University of Michigan. Bernardo Huberman, who's coming next week, was my boss both at Xerox PARC and HP Labs, and I very much recommend you go to see his talk. He's a great public speaker. So today I'm going to talk about some aspects of my work on inference on the social web. So I very broadly work on how people produce and consume information, largely with a temporal component associated with it. Today I'm not going to talk so much about the temporal component, but rather the way in which individuals and then communities observe kind of events, consume those events, and then produce them somehow digitally. Okay, so we're going to try to understand what they're doing. We're going to try and actually leverage that to some extent. We're going to try and see where these things fail. So not just the individual, but the communities, which is kind of the more interesting thing for me. And I'm going to do this in 4 acts, just as a cute way to structure this, because it is tying in a bunch of different things. So the 4 different things that I'll talk about today is the reality that different people react quite differently to events that they observe. Okay, so if we see something that happens out in the real world, some people react to it very quickly and produce some new content, whereas other people might react kind of slowly, and other people might react again very differently. So the notion of this first study was to look at different ways in which different communities and different individuals consumed and produced content. Was there some relationship between these different reactions? So if something happened out in the real world, some news event, how did different communities react? The second thing is actually trying to leverage the things that are being produced. So if different people are saying different things, different communities potentially co-evolving, they're working together, how can we actually make something useful out of that? Hopefully producing something and then feeding it back into the system. So I'll talk a little bit about this in terms of an inference problem, specifically in the context of Wikipedia, where different people are producing content for different language domains, and we're going to want to try and help languages that are sort of underrepresented using the content, the work of other people. The last thing in terms of new developments I'll talk about is dealing with the negative impact of this. So there's this kind of optimistic view of the world in which everyone is producing a lot of great content, and if we just mined it correctly, we could really do some astounding things. But I'll talk about situations in which the particular structures of the group, of the social dynamic of the group, might actually lead to incorrect things being generated. So sort of people combining information by looking at what others have done and bowing to social influence and social proof in order to produce the wrong thing. And the last thing that I'll talk about is kind of ongoing work in all these areas, but specifically ways of breaking this over-reliance on social signals. So let's start with the first act in which we taste the flavors of social media and vinegar. The name vinegar for this project came out of this observation that, from an article that I read in the New York Times, that the SARS epidemic, which started in a little province in China, was reacted to by the local population in a way that was very interesting. Basically, they bought out all the white vinegar in the local stores. And this was well before anyone else realized there was a problem. All the white vinegar was gone. And what happened was basically the community was reacting in a traditional folk medicine way, which is boiling white vinegar in the home in order to fend off this bad thing that was happening within the community. So basically the community was reacting well before any health officials could actually see that there was a problem to deal with. And other people, of course, have observed this. Google Flu Tracker of Google Flu Trends does this. How many people have seen this before? Okay, a few. So what Google does is it looks at search terms related to flu. So anything about symptoms, medication. Did I lose the mic, or is it?
I think you're okay.
Okay, so anything with related to the flu is basically predictive when people search for it of actual flu going on in the real world. Now, there's certain situations where this doesn't work. Swine flu, for example, everyone self-diagnoses themselves as having swine flu or wants to know if they're about to die. So you see these weird spikes in the behavior, which are not indicative of actual flu prevalence in the US. But in general, it works. So unless there's some weird situation going on, Google is very accurately able to use the behavior, the online digital behavior, in order to do some really interesting inferencing to tell that there's something going on in the world. And what we asked with vinegar was the question of how our daily digital behaviors relate to these kinds of external events. So we looked at search behavior, we looked at blogging behavior, we looked at things that were in the news and things that were on TV as different kinds of sources of media that we could look at. So the questions were addressed by looking at very large collections of data. So we had 27 million queries from AOL and Microsoft. We had 14 million blog posts of 3 million blogs, 20,000 news stories, and about 2,500 shows. And all these happened in May of 2007, I believe. Okay? So this was where the source of the data was from. And basically, we had some techniques, which I'm not going to go into too much, just to get into kind of the meat, like to show you what was different in these different communities, where we basically transformed these behaviors into time series signals. So we took the text, so the number of mentions of a specific query over time, the number of blog posts on a specific topic, and so on, and transformed it into a time series, which then we could actually compare. So we built this tool for analysts to use. There's kind of some technical details that are maybe interesting, but I'm not going to cover too much. If you're really fascinated, you can take a look at the paper. But basically, it was a visualization tool that allowed an analyst who had some hypothesis about the relationship between the reactions in different communities. They could test those on a specific topic. So this was for the TV show Lost, which was popular, I guess, up till a couple of years ago. And you see these kinds of peaks, both in the AOL and MSN query behaviors. Anyone want to guess why the peaks are there? This is about a month's worth of data. Wednesday night, right. So a peak basically represents the time that the TV show was on. But you can see sort of different reactions quantitatively in the different populations. The tool also supported this notion. There's some algorithmic magic in order to figure out which queries were related to each other. So the word lost, of course, is mostly about the TV show Lost, but numbers like 4, 8, 15, 16, which is kind of a major theme in the show, and Flight 815, all of these are queries that are related to the topic, were dynamically extracted, and the user could kind of go and filter out things that they didn't think were relevant and so on. So the tool allowed this kind of exploration. There was also this kind of neat summary widget that we called the dynamic time warping radar, which basically let people have this nice summary of the differences between the two different communities. So using this and looking at a lot of the behaviors that were going on during May of that year, a lot of the topics that were happening, we started asking the question, asking specific questions to the event. Are the bloggers responding quickly? Are the general population of searchers responding? Why are they responding? So is there some mechanism that's motivating that kind of response? And when are they responding? So when do certain people lead or lag behind others, okay? So let me just go through a few of these, which is what I think is kind of the interesting bit. So we had a bunch of cute names for the different things that we observed, and I'll talk about the first three, which is news of the weird and anticipated effects, and familiarity breeds contempt. So, okay, so here's what we're looking at. News of the weird. These are different observations, again, that we studied qualitatively in these different data sources. So the first thing that we noticed was that bloggers pick up sort of weird stories first. Okay, so if we look at the behavior, sort of the amount of blogging done on a specific topic, like Igor Vovokovinsky, we see that that leads well in advance of search behavior. So the peak in blogging behavior anticipates kind of a peak in the general public searching for more information. What Igor Vovokovinsky is known for was having size 26 shoes. Okay, and this is arguably not like top of the fold kind of news, but bloggers tend to respond to this. Okay, and I'll explain why in a minute. But basically, they talked a lot about it. They found this to be the most fascinating thing ever, and there are a ton of blogs dedicated to this news story because they thought it was interesting. Same thing with the USS Oriskany. The blog behavior led search. What the USS Oriskany was a ship that was decommissioned by sinking. Okay, again, not top of the fold news, but the bloggers find these kinds of things fascinating. And there's a couple of reasons, but let me, before I explain why bloggers lead in these kinds of news of the weird, let me show where they follow, which is that bloggers don't like to blog about anticipated events. So if they don't have something new to say, they tend not to talk about it. So Preakness, which is a horse race, okay, we see that search behavior kind of goes up and up and up early. The peak over here is when the actual horse race happens. Search is leading because people are looking for things related to the race. They want to know which horses are racing. They want to know the different times of the races and so on. And the bloggers tend not to jump in until they have something interesting and unique to say. Same thing happens with TV shows. People search for, a brief description of what's going to happen on TV. They want to know what time it's on, if there's any change in the schedule, and so on. So there's a lot of search behavior that comes first, whereas blogging behavior comes later when the bloggers have something snippy to say about the TV show and what they liked and didn't like. So what's motivating these two behaviors, the news of the weird and anticipated events, is basically bloggers tend to like to be different. Okay? They get increased viewership by basically distinguishing themselves from kind of outside news sources. So if they overtalk about things that everyone knows about, no one has any reason to come to the blog. Okay? And what we saw over and over and over again is that bloggers will pick these stories kind of from the bottom of the fold because they know that traditional media is not discussing it heavily. It's not something that's featured in the news. It's not something that's featured on the front page of CNN. But it's something that their readers will appreciate in some way, either because it's funny or because it's interesting and so on. And so they don't react until they have something new and different to say. Okay? So that's why we think these two different kinds of things happen. The last one that I just wanted to briefly mention is this idea that familiarity breeds contempt. Okay? And that this is about a more general population rather than just bloggers, which is that people in general seem to get tired of things that are happening and that are being treated extensively in the news. So if we look at the amount of news postings about the Enron trial during May, we see there's a bunch of news. There's like this continuous hum of news about Enron because there are some people that are interesting. It was an important news topic, but we see very little amount of search up until this point, which is basically the time in which the verdict was passed. Okay, so at that point, when there's something new, people are really reacting to it. So even though the news media feels that there's something interesting going on, the behavior of the population in terms of search is clearly indicating something else. Right? This is why we call it familiarity breeds contempt. We've seen it. We've become immunized to these kinds of events going on, and so we no longer pay attention to them. OK, so before I move on, just to summarize this, the key ideas, I think, and this will be important for the rest of the talk, is that there's really a lot of behavioral differences in different communities. So people react very differently to the same kind of thing. And sometimes they're motivated by social pressure, sometimes they're motivated by personal interest. But the thing is that there are these differences. And the question that we ask next is how we can actually leverage these to do something better. How can we actually leverage them to do something better when the different communities actually want to be synchronized, where they want to know the same things? So the second act is one in which we actually try to do something interesting with the data that's being produced by these different communities. We're going to try and do some language learning without a dictionary, which is kind of interesting. We're going to try and build ziggurats, which are basically a Tower of Babel, and draw the ire of the wiki gods, but not so much. So in Wikipedia, most of you probably have this experience with Wikipedia, that you treat it, you hear these statistics like there are 16.3 million articles, and you probably have some instinct that most of those aren't English. But that's actually not so true. The reality is that only about 20% of the 16.3 million are English articles. Okay? And this number is actually dropping. So when I first gave this talk in 2009, the numbers were actually quite different. The number of English articles was much higher as a proportion. The rest of the articles are kind of divided among 260 other languages. Okay? So 12.9 million articles. So this is the Wikipedia language domains by rank. And you can see that some of them have really a ton of articles. Okay? So French, German, Spanish, the ones you would traditionally expect really have a lot of articles. And then there's languages that really just don't tend to have very many pages associated with them. But the number of pages is distributed among this like 260 different Wikipedia domains, language domains. So the question that we asked was why this happens and what the differences really are. So in many situations, you really have the same article or the same concept that's being talked about in two different language domains. So Jerry Seinfeld, the comedian, has an article in English and has an article in Spanish. Anyone want to guess which article is longer and more detailed? Okay. Clearly, a ton more details about Jerry Seinfeld in English than the one in Spanish. Okay? It's not that necessarily the Spanish speakers don't care, but maybe there aren't enough bloggers that are actually interested enough to blog and enough to edit the wiki articles and kind of modify them to keep it up to date, to keep all the details that are possibly relevant to the English readers up to date in Spanish. Bonlieu is a little town in France, and so the French article and the Spanish article, many more details in French, obviously. The interesting thing is not only are there more details, the details are much more up to date. So the census records, for example, in the French article are kept current. So the French numbers at the end are much more recent than the Spanish ones. Okay, so there's clearly this difference in the two different communities in terms of how up to date they keep in the content. And this is, of course, much better than the Hungarian page, which simply just doesn't exist. So there's no topic, there's no page for Bonlieu in Hungarian. The problem, kind of the result of this differencing, is that you might have two different languages, and depending on the visitor and which language domain they visit, they might get very different quality of content. So this is kind of a silly example, but one that makes the point. Emmanuelle Berthe is a French actress, and so there's a pretty regular updating of her content. And in English, that's not so much the case. So the number of updates that her article gets in English is not so frequent. The problem is the visitor that comes at this particular time point, going to the French page will get many more details, which is great. They'll also realize that she has 2 children and a new husband, which is maybe not so relevant, but the one who's going to the English page, who's maybe trying to understand something about Emmanuelle Berthe, is going to experience the wrong details. Okay, so this is kind of the problem when we have this mismatch between the different communities. Despite the fact that they're both trying to co-evolve, both trying to keep the thing updated, there's clearly many more French Wikipedians, editors, that are going to keep this up to date. Okay, so the idea that we had was basically to leverage the work of one community and push those details and update the community that's not updating as frequently. So pretty straightforward. We have people doing a lot of work and people not doing as much work. Why don't we translate and move these things across? How this works is also pretty straightforward, although there are some kind of hard technical details that I'll skim, but I'll give you some sense of the challenges in doing this. But at the end, you'll see that it is possible, which is kind of the interesting bit. So the general idea is that we find situations in which there is equivalence, in which the two different communities have somehow aligned themselves. So spouse and cónyuge in Spanish have both aligned to Jessica Seinfeld in the case of Jerry Seinfeld. So we learn that there is a mapping, if we see this often enough, between spouse and cónyuge. If we have somebody like Tom Cruise where spouse equals Katie Holmes and this particular piece of information is missing, because we've learned that there is equivalence, we can then feel safe in pushing that data between the two different communities. Or if there's a less recent wife for Tom Cruise, we can also feel more comfortable pushing or offering to push that within the Wikipedia domain for Spanish. Okay, so this isn't intended to be kind of this general tool that works on any language just in pure text. We mostly concentrated on info boxes, so kind of to make the problem a little more manageable, but still challenging, we concentrated on the semi-structured information, key value pairs largely, of the info boxes. So we have info boxes. I'm sure you've seen this if you've ever gone to Wikipedia. We have info boxes for schools. We have info boxes for people, for events, and for other institutions. Okay? And we took basically all the Wikipedia for English, German, French, and Spanish from January of 2008. Articles are in this thing called Wikitext, which is, for those of you who have worked with wiki stuff, is evil. But basically, it's this really ad hoc combination of text, HTML, and wiki markup. And the nice thing is that these very nice people in DBpedia have actually gone through and parsed a lot of this and given us some clean data. Okay. We did need to do some cleanup on our part, but at the end of the day, what we had was about 12.8 million English articles, 2.1 million German, 1.5 French, and 880K in Spanish. So the info boxes, basically, as I mentioned before, have a class associated with them. So this is the Olympics info box, and that's the Hochschul, or the college info box in German. I apologize. I have to switch between 4 languages, and I may start butchering things quite significantly as I go. But so that's the college class in German, and everything has keys and values. Okay, pretty simple. Ziggurat is basically a system that was supposed to take this data in and do this kind of mapping, so learn the mappings between the different domains, and then push data across. So the way it works is as follows. We look at this in terms of 3 steps. First step is page alignment, where we try to align the pages in German to their corresponding pages in English, to their corresponding pages in French, and so on. So we have the English Wikipedia and the French Wikipedia, and we do this article alignment when possible. Okay. The next step is infobox key alignment, where we try to map the different keys in one infobox to the keys in the other, where this is possible. So this is part of the learning exercise. So we find those situations in which there is synchronization between the two different communities in order to learn this mapping. So we learn these probabilities, basically, that things like spouse and conjoint is 0.9, the probability that those two things are similar, whereas the probability that parents and nom in French is pretty unlikely to be the same box. And once we have these probabilities, we can do this infobox completion. So if I have a very incomplete box, say in English, the idea is to take the German box, the French box, and the Spanish box, and basically use those in order to grow the amount of content that's available in the English box. Okay, so let me just walk you through a few of the technical details and some of the challenges, just in terms of these 3 steps. So page alignment works in a pretty straightforward fashion. We basically try to find all the pages that have something to do with that topic. There's a little bit of trickiness. Not every page is linked to the page in the other language, so we have to do some learning on that. Some pages are split. So you might have a author that has an author page and a bibliography page, 2 separate pages for the same entity, and so on. But basically, in general, what we're going to try and do is this mapping. And for the most part, we can rely on the links that are available on the side, which maybe some of you have noticed before, but they don't always exist, so we have to kind of do a little bit of smart hacking in order to get this alignment to work. Okay, so that's a relatively straightforward step. Kind of the more complicated step is learning these probabilities. So learning that country name, so the info box class country with a specific key name is somehow equivalent to pay in French nom. Okay? And again, as I mentioned, what we're going to try and do is find those situations in which there is explicit equivalence or something that looks like equivalence. And the something that looks like equivalence is the tricky part, because United States of America and États Unis d'Amérique is similar in terms of n-grams, but in terms of character n-grams, but is clearly not equivalent in terms of text. Okay, so we're going to try and do something a little smart there. The notion of equality is tricky, not just because of these different translations of the values, but very simple things like word ordering, the translations, different ways of typing in numbers in different languages, numeric translations. Okay, so 12 kilometers equals 7.4 miles, 7.45 miles, but we wouldn't know that unless we knew something about conversion. Pingtung is equal under containment to Taiwan. Okay, so this is something that we need to learn, Pingtung being a province and a city within Taiwan. And we need to know that raisin in French does not equal raisin in English. Raisin in French being a grape and not a raisin. Okay? Okay, so we need to have some concept that there are things that are equivalent and some things that are not. So there's a little bit of trickiness there. The solution that we did, and there's I think better ways of doing this in going on to the future, but this worked effectively in the first go, was that we really wanted to build a single classifier that would take in 2 values and tell us whether the things were equivalent. Okay, so this is where we break down into 2 separate parts. So we have the single instance classifier and this probability estimation. So let me just go through the math really quickly, not so deeply, but enough to give you a sense. So there's a bunch of features that help us make a decision about whether 2 things are equal. I'll talk about just briefly the first 3. So there's different things that we can do. So one thing that we can do to figure out if two different phrases are equal is to just look at the term overlap. So if we split every phrase, like the Great Gatsby, into what's called a bag of words and treat that as a set, and then look at the overlap. So the Great Gatsby and Great Gatsby the, as sets, just random sets of words, have a pretty good overlap. So this is a nice signal. We can use something that's called the dice coefficient in order to figure out the overlap between these 2 things. Okay. The other thing that we applied, and it turns out that this is actually not necessary for the languages that we used, is a dictionary. Okay. So a common problem is that certain words in one language are not equal in another. So public university in English could map to a bunch of different things in French. And so we use this dictionary as an attempt, but we ended up not needing to use it in actual practice. A dictionary that maps public to all possible French versions or German versions of the word and so on. So public university gets translated into Public Ouvert Universel, University Academic College. Okay? So all these different things basically are reasonable mappings from public university to something that's in French. And again, what we do is we take this bag of words in the translated domain and compare it to the target in French. So this is what the French actually say, Public Université. And so we compare the bag of words and we see how many times we can actually get a hit. Okay. The last thing that I want to talk about very briefly is correlation features. So we actually learn by looking at all the numbers in the system that there is a mapping between these 2 different things. So pays superficiel total and country area 12 kilometers squared and 4.6332 miles squared is the same, and so we need to learn it. We can either hard code the transformation, but we thought it was really better to do this automatically. And the way we do that is we looked at all situations in which there was numerical data in the two info boxes, and then just did a simple correlation plot. And we found that there was a mapping, and if the mapping was good, then this became part of the translation process. Okay, so every time we would see a number, we would try to apply this kind of mapping in order to get a new value, and then we could decide whether two things were equal. Okay, so we take these values, we basically do this for every pair of things that we see, and we can learn through this classifier using some training data that two things are equal. The only trick that I wanted to mention is basically how we get the training data. So if you're trying to do this and you don't want to manually go through and do all this manually, then there's some tricks that you can apply, specifically something called self-supervised learning, which is that using things that are likely to be correct to generate more data on which to train. So things that we consider likely correct are those situations in which there are many instances of exact phrase equality. So let me give you an example. So country capital equals Paris equals pays capital, and we see this over and over and over again. So in English and in French, we generally see a mapping between country capital and pays capital. Okay? So that tells us it's a pretty good indication that those two things are equal. Okay? Then we have things that are really bad. Okay? We see sometimes that latitude equals population range, and sometimes common names equals plus grande ville, like the biggest city, which doesn't really make sense. This doesn't happen very often, but it does happen. But we can basically find a cutoff which is reasonable and say things above the cutoff are likely to be good and things below the cutoff are likely to be bad. Okay, so good examples, bad examples. And what we're going to then do is use the good examples in order to generate data for our system to learn off of. The reason this is interesting is because we want to find those situations in which we know that name and nom are likely to be the same, but in which the values are not the same. So Italy and Italie are different spellings, okay, in English and in French. They refer to the same thing. But we know, again, that name and nom, based on our previous experience, is very likely to be true. But we find those situations in which the keys are known to be similar, or known to be equal, but the values are known to be different. So Italy and Italie become an example of a positive training example. So those are the situations in which there's no equivalence in a purely textual term, but there is equivalence that we can then later use. So we took about 20,000 of those, and then once we have identified a good mapping, we pick at random some other mapping that's known to be bad. Okay, so from those two info boxes, we know that the water coverage of a country, given that we've already aligned name and nom, so name is very unlikely to be ever equal to O, the water covering of the country. So we use those as basically negative training examples. All right. So we feed all this into the system. We basically get some value using this training data of 20,000 correct and 40,000 wrong. We train the system. We learn this binary classifier, equivalent or not equivalent, pretty straightforward, that then learns the 0, 1. In order to get these probabilities, what we do is we generate lots and lots of different pairings, lots and lots of different examples, and we then run the classifier to find equal pairs. And then we basically calculate this kind of hackish probability where we look at the number that are evaluated to be equal by our system versus the number that are tested. And we kind of get a sense of these probabilities. So how often is it that name and nom are the same, and so on. So we learn the probabilities of these different mappings. Okay, so just to wrap up, what do we do with these probabilities? There's a lot of different ways of choosing keys to fill in automatically. What we do is find situations in which there's holes, basically, in the article, in the info box where there's missing information. We do that because we know that English Tom Cruise and French Tom Cruise are the same article. We know that in the French article, there's a personne info box and an acteur info box, which are both reasonable. Okay? We map those to person and actor. We know that those two info boxes are the same. We then do this mapping to person and actor. We look at what are usually used keys in person and actor. So a person has a name, a person has a spouse, an actor has an awards, and so on. And then we say these are the fields that we want to fill in for Tom Cruise. So this is the missing information. Tom Cruise has no info box. We will use the data, what we know from the French article, in order to populate this. Once we have the missing holes, we can basically make some decision about how to fill them. We can try and find the best thing in which to put, the best value to put in, kind of independent of all the other keys that we've picked. So we'll just one at a time go through name, go through spouse, go through awards, and try to find the optimal mapping, the optimal thing to fill in with the missing information. We can also do some more clever things like maximum weight matching, which basically tries to look at everything simultaneously between the French and the English and tries to figure out the best way of mapping. Okay, so to give you a sense that this actually works, the single instance classifier is pretty good, making that decision. The interesting bit, again, is that 90.7% accuracy only drops a little bit if we remove the dictionary. Okay, so we don't actually need dictionary features. We can actually just learn these things automatically. Okay, so we do pretty well just without the translation feature. So you don't have to have some huge manually constructed or automatically constructed dictionary. The system kind of does that for you, which is pretty cool. You're using the work of many, many people in order to actually automatically construct a dictionary. Okay, for the probability estimation, let me just give you the high-level bit, which is that at the end of the day, we get about 86% right. So this is the number of proper mappings that we make. Now, it's not always the case that what we consider wrong is actually wrong. It's just potentially not the best match in the world. But 86 precision is pretty good for not having much background knowledge or doing anything really sophisticated. So basically, these are 86% in terms of how many things we can fill in correctly. So holes that are missing in the Tom Cruise article in English, how many of those do we fill correctly using French, Spanish, and German? The last thing is recall. So how much of the possible space of things that we can fill in do we actually fill in? Now, this is a little bit more challenging to calculate because if you've ever looked at Wikipedia in terms of the internal structure, if you've ever edited Wikipedia, the problem that arises is that every language domain has 50 zillion different info boxes for the same kind of thing. Okay? So there's lots and lots of possibilities about what we might fill in. Okay? So there's many, many ways of talking about actors in English. There's many, many ways of talking about universities in English. Same thing in Spanish. The only one that's pretty conservative in this is the German Wikipedia, which is pretty strict about the number of info boxes and how those info box classes are defined. So the Germans are pretty regular. They have one kind of person info box, the Personendaten, and I'm sure we can make some joke about German strictness, but the Personendaten is kind of the thing that everyone uses in German. So we can do pretty well with the German case. But in the other ones, the only way we can evaluate recall is kind of the number of possible missing things that we might have. And this unfortunately relies on the whim of any Wikipedia editor who can kind of add their own new keys into the system, which are not necessarily popular or used highly. And what we see is that if kind of the current average is the number of, on average, the number of info boxes that are filled in, the number of keys that are filled in, and the maximum, the number of total, we tend to add a little bit. Okay? Now, this is not wrong, so you shouldn't look at it as, oh, you could have gone to max. The reality is that we don't actually want to go to max, because if one particular Wikipedia editor thought that this key was really, really interesting, but no one else did, we really shouldn't populate that key in other languages. Okay? So that particular attribute of a person, of a university, of a whatever, is not really relevant. So we don't want to pollute the data because one person in English said that this was important and no one else in the world thinks it's important. Okay. So we see this kind of thing over and over and over again for all the languages that we have. Spanish in particular we do pretty well in because Spanish has a lot of holes. The relative percentage of articles that we have in Spanish is much, much smaller than we have in English. So we can actually do something that's really kind of neat, which is fill in a lot of missing data within Spanish. We can also create a lot of Wikipedia articles that didn't exist before in Spanish and stub those out with some of the info boxes, creating information for the Spanish-speaking population that wasn't available before, which is kind of neat. So just before I move on to the last bit, which is kind of the most recent work, and probably the one that's kind of most exciting, is that the work on Wikipedia is really diverse in terms of the people doing work. And there's different populations that care differently about different kinds of topics. So their expertise and interests are somewhat localized. But that doesn't mean that the person in the US doesn't care about a topic. They might want to go and visit Banlieue. They might want to know certain aspects of that little town in France. So that ability to have that information automatically filled in is, I think, really important and interesting. So the availability of that data is something that we should leverage and kind of embrace these differences as an opportunity to do something better. Okay, so very briefly, let me talk about this Act 3, in which there's an actual situation in which we're not doing so well in terms of using social data, and where social influence is actually doing the wrong thing. So in this case, we have co-evolving communities, but they're kind of independent of each other. They're not really signaling to each other. The notion that we have here is that there are situations in which people are communicating which are potentially problematic. We looked at specifically this idea of collaborative visualization. So I think Fernando was here probably a little while ago talking about many eyes. We think many eyes is awesome, but we also recognize that there might be some interesting challenges that emerge in lots and lots of people looking at the same data in different ways. Okay. So there's a lot of really statistical anomalies that might emerge. People go on fishing expeditions, like so many people looking at the same data set will inevitably find something that they think is interesting. This is known in the data mining community sometimes as finding that the best predictor of the S&P 500 is the butter production in Bangladesh. Okay, so if you just mine lots and lots of data, you'll eventually find these kinds of relationships, which are absolutely false. Like, they don't make any sense whatsoever, but the numbers just work out to be that way. Okay. The other kind of interesting thing with visualizations in particular is that they represent a shorthand. Okay, so they're really subjective in terms of interpretation. There is no really easy way to take text and convert it into some numerical value, which then can be encoded in a retinal variable. Okay, that's not a natural kind of conversion for us to make. We've figured out ways of doing it, that text should be represented in this way and plotted in this way with this colors and so on, but that's not really a natural thing. And that level of abstraction potentially causes people to see very different things when they're looking at the same data. Whereas when we're reading something, we can interpret things differently, but we're reading things when we're looking at text we're looking at the same source of data. Okay? But visualizations are this kind of abstraction, potentially a lossy abstraction where things can go bad. Okay, so a very simple first thing that we've done with this, and this is work that's going to be talked about at CHI 2011, is in terms of graphical perception. So this is not any higher level functioning within a visualization system. This is kind of low level perception in collaborative environment. So what do I mean by graphical perception? So this has been a standard problem within the statistics community. Those of you who follow this work, it's been around from the 80s and before that. Cleveland and McGill are famous for doing this, where they basically looked at the problem of what's the best way to visualize data in terms of our ability to determine differences between different pieces of data. What's the best representation? So should we represent the same data as a pie chart or as a bar chart? Okay. What do people read better when they look at it? Okay, so they did this kind of analysis. They did these different tests, lots and lots of different experiments, to determine the most optimal kinds of layouts for bar charts, pie charts, a bunch of other kinds of visualization techniques, basically identifying the things that were best in terms of error performance. So which are the things that people make the least mistakes on? So the two dots in each visualization are the things that we're comparing against. What they asked people to do is tell me which one's bigger, this dot or this dot, okay, this bar or this bar, and by how much do you think it's different? And then they looked at how wrong people were when making those kinds of decisions. So this was repeated most recently in 2010 using the mechanical Turk system, basically replicating an experiment that was done in a lab previously, kind of identifying the same results. And what we learn is that people are really good with bar charts of a certain type and less good with area charts. And so this kind of confirms what was known in the psychology community early on. Okay, so that's half the problem. So this is what I show to an individual. The second half of the problem is now that I have a situation in which lots of people are looking at the data at the same time. So this is a famous experiment by Ash from 1951, the social influence experiment. Basically, a bunch of people would sit in a room. Some were Confederates and a person would be shown a card with this bar. Okay? And they would be shown a card with bars A, B, and C. And they would be asked to say, which bar is this one most similar to, A, B, or C? Now, most people can tell that C is probably the most similar in size. What the Confederates did was pretended, basically, that bar A, or whatever bar, the not right bar, was actually the right match. Okay? Basically convincing the subject to make the wrong decision. So influencing them, convincing them in some way that that was the right thing to do. So this was kind of the first the initial kind of classic experiment, and the only one that uses any kind of perception. There is a few other neat experiments that are more recent in this regard. Which is the more attractive face? Okay, there's actually, if you ask people, it's about equal. Okay, so people tend to think that both of them are equally attractive. Now, which is the most attractive face? So it turns out that women will tend to prefer the left face more, whereas men will dislike this face and prefer the other one more. Anyway, it's kind of interesting. But social influence in general has a lot of issues in terms of measurement. There's a lot of cultural aspects. The interest in the topic being displayed to you. There's notions that this changes over time. And there's differences between normative and informational. In order to make this simple for us, we're going to concentrate on purely informational things. What is meant by normative is whether the person telling you something is non-anonymous to you, okay? Whether you have some notion of their expertise, who they are, how much you respect them, and so on. We don't want to have too many of those signals. They become really difficult to tease out. So we're going to concentrate on the informational. So this is that comes from this concept of social proof. This cartoon is kind of a nice exemplar of social proof, where people start staring upwards. The first person stares upwards, and then more and more and more, and the angel finally looks upwards. Okay. So this is the notion of social proof, and we see this in restaurants, right? Like if you're trying to decide between two restaurants, you think that the better one is the one with the line outside. When you're trying to decide which music to listen to, you pick the one that's kind of more popular. Same thing with tagging in things like Delicious and Flickr. It turns out also follow this kind of thing. Basically, you look at what other people have done in order to decide. So it turns out that it's kind of random whether you pick tag A or tag B initially, but once that first person makes the decision, everyone follows them. Okay. So the question for us in terms of visualization is given the fact that we can have social signals within visualization environments, does graphical perception get better or worse if I give you some social signal? Okay? And the second thing is, do information cascades happen? So does the n+1th person behave differently than the n depending on what the n is? So if you're the 5th person to look at something, do you behave differently than the 6th person and the 7th person, and so on? Okay, so the experiment is fairly straightforward. Let me just fly through this to give you the interesting result here, which is that, so we used the mechanical Turk. In order to create the social signal, what we did is we used the standard Cleveland McGill and Jeff Hare and Bostock experiment. We showed people a bunch of visualizations, a bunch of mechanical Turkers. They gave us this estimate, which was how similar, which was the ratio that they thought these two things were either equal or not equal. Okay, so how much is the A dotted bar a proportion of the B dotted bar? And so we have some nice distribution of this data in terms of the proportion estimate. Okay, with this data we have the mean, okay, and a standard deviation away. And what we do is we basically generate two histograms, one corresponding, one centered at the mean, and one centered on one standard deviation away. So one representing kind of the accurate estimate, and one representing an inaccurate estimate. We repeat this experiment, this time showing them this visualization plus a histogram of either the correct or the incorrect social signal. So what did other people say? Right? What do you think happens? Basically, what happens is that when we show them a good signal, their errors tend to be lower than no signal at all, which tend to be better than getting the wrong signal. So when you get the wrong signal, okay, the wrong social signal, seeing the same visualization, you tend to make more mistakes. Okay, this would be somewhat reasonable given what we know about influence. But it is significant, most of these things. The target M and control, depending on the situation, is not as significant. Sometimes we can't actually do any better than the individual system. So it's not always the case that we can do better by giving this kind of signal. All right, so the answer to the first question is yes. Okay, tasks get better or worse depending on the quality of the social signal. And the second question is, do information cascades happen? So very briefly, what we did in order to check to see whether people respond differently if they think they're the 10th person to look at something or the 100th person to look at something was really quite simple. We basically changed the number of people that we showed in the histogram. Okay? So the means and in both histograms were both the correct and the incorrect were chosen to be the same. The only thing that we varied was the numbers, the frequency that we had. So we told people, you are the 50th, and this is what the 49 people before you said. So, question, does it matter if I tell you that 1 or 5 or 10 or 100 people said that the value was this? Yes or no?
Yes.
No. So this is kind of surprising. It turned out, and we're still trying to figure out the reason, it turned out that even a signal from one person was pretty good at getting people to say something wrong. So even that first social signal tended to tell you, it tended to change your behavior in some significant way. And the difference between these things were not so significant, okay, which is kind of interesting. We're still trying to tease out why this happens. So yes, they happen, but really it's just the first social signal that sets people off. So it's not the case that you become more confident in this particular case as you see more and more social signal. What we think is happening a little bit is that in the situation is that the true value, it's usually assumed in these kinds of situations that people are pretty good at estimating either below or above what the true value is. So if we look at the distribution, what we'd hope to see is that the true value of that proportional difference is equal to the mean of the estimate. It's not actually the case. So it turns out that in graphical perception tasks, there's some systematic bias. Okay? So people kind of either overestimate or underestimate, depending on the situation, such that the true value does not equal the mean. So we're always a little bit biased, no matter what we do. And what this does is that this feedback, this bad feedback loop, because it's biased here, will basically keep escalating, and people seeing this signal will keep generating the wrong thing. So even if we take out the social signal, people will always say the wrong thing. And given just a slightly leaning social signal, one that confirms your beliefs that it should be just a little bit more in terms of proportion estimate, people tend to do the wrong thing. So this is a quote that I like. A person is smart, people are dumb, panicky, dangerous animals, and you know it. Anyone know where this came from? Men in Black. Okay. So it's kind of my favorite quote to kind of describe this. But let me just really, really briefly say how we think we can solve these issues. So we have lots of ongoing work in these different areas. We're looking at the spread of ideas, so trying to model the telephone games and networks. We're trying to do better within the Wikipedia stuff, actually trying to translate text and not just info boxes. And we're trying to do better with the collaborative visualization, which is getting back to the benefits of the group without kind of the bad feedback that happens with social influence and social signals. And so there's lots and lots of different ways of doing it. What we're trying now is to expose people to variance. So because we know that people are going to do the wrong thing given the same input signal, what we do is we introduce slight variance of that input signal. So I'll show you slightly different visualizations that all correspond to the same data in the hopes that different people exposed to these different signals will make different kinds of mistakes. Some will overestimate, some will underestimate, and instead of getting a really bad view of what's going on, we'll get somewhat of a better view. Okay, just to summarize, a couple of really quick final thoughts. I think there's a tremendous opportunity in social data. So people are producing this all the time. Okay, our digital kind of online behaviors are really producing so many status updates, so many little behaviors like search and visitation to different kinds of websites. And looking at those signals, I think, is important and gives us a lot of power in order to figure out what's going on in the world. And this is done in this kind of non-reactive way, where we're not actually asking people to do anything. We're just looking at where they go and what they're doing in order to infer that. The key, I think, in doing this right, though, is to recognize how and for whom this data is being produced. Is it being produced for the community itself? Is it being produced for the individual person? Are people generally biased or not? And knowing this, I think it's possible to then use the signal and do something better without really succumbing to the noise and getting the wrong values. So understanding how this happens, I think we can do much better. So with that, I've run a little bit over, I'm sorry, but thank you. And if you have any questions, please feel free to stick around.
So yeah, in your previous experiment, what you did is you gave one of the groups false, 1 standard deviation to the right. So were the answers like closer to the correct answer than what you gave them, or did it get even worse? So do people tend to come back to the right answer or not?
Eytan, could you, sorry to ask, but could you summarize the question?
Sure.
For the recording?
Let me make sure I understood the question correctly. So you're asking about the 1 standard deviation.
Right. So what's the result? So the correct answer was in the middle, then you shifted it by 1 standard deviation, and then you polled again.
Right.
So was the result in between the two, or was the result?
No, it was further to the right. It was
further to the right than that which you gave them?
No. Sorry, no. It was closer to what we gave them. It was always close to the mean of the signal that we gave them. So when I showed people this, they tended to pick a number that was at the peak of the distribution. So they didn't pick something that was further off than before.
Were they correct in it, or were they making it even worse?
They were correct in figuring out what the histogram said, but wrong in actually estimating the number.
Kind of on the same topic. So you said the main effect is if one person before you had the wrong answer,
yep,
you will be influenced to tell the wrong answer as well.
Right.
And pretty much that's the first order effect. Then whether I'm 1 or 75 people before me.
Yep.
So when you have only 1, if I understood the description of your experiment properly, I would have only 1 bar.
Yeah, only 1 bar. Right.
Well, doesn't that make this extremely salient compared to just a histogram for 75 people? When I have 1, it's like there is no statistic for 1.
Right.
Somebody did this before you, he thought that.
Yes, that's right.
As opposed to 75, to me, I don't know. I don't know, I'm not an experimentalist, so I don't know how we discriminate that, but to see a single bar as opposed to just a distribution, to me, it would feel that would make something more salient.
You'd think. So the question is, would 1 bar be more salient than many? But I think in part it's explained by bad visual or statistical literacy, like they don't understand what a histogram represents. Although they do know how to read a histogram, we do test them on that. But having just the bar to them says, okay, I'm going to go with this number because I don't actually know, and like this seems like a reasonable thing, so I'm going to be influenced by this. I think there's ways of teasing out why this happens, but we haven't, fleshed that out yet. I think there's other experiments, but we thought it was really interesting that just the 1 signal was enough. That people don't seem to estimate better when they're told that 50 people said something than
But could there be a
1.
way to maybe fake a distribution even if you have only 1 person?
Sure. Yeah. I mean, you can generate a Gaussian centered on the on the 1.
And the effect is the same.
Yeah.
You try that.
Yeah. Right. Yeah.
Then it's probably not as salient.
Along those lines, is it possible maybe to alter the question so that people are more comfortable? Because I don't know, I feel like in general people aren't as mathematically capable of figuring out something like that versus like asking a question more like pop culture related and then having someone figure that. So
Sure.
if they're not sure if their answer, they might just go with the bar.
Right. Right. So we looked at tasks of different complexity, and the thing seems to be pretty consistent. People tend to guess wrong even when the task is easy or the task is hard. it's true that social influence works differently depending on the interest level that a person has in the topic. So the bars are meaningless, right? Like they have no labels. So people may just not care. But they are paid to perform well, right? So we tell them that if you guess wrong, we won't give you your money. So we kind of enforce them to care a little bit. So even if they're not interested, they're trying to maximize the profits that they make, so they'll try.
I was curious about how you decided which way to push info-box material. So maybe Jerry Seinfeld would think, oh, that's a U.S.
Mhm.
American kind of thing, but what do you do with David Hasselhoff? Particularly because maybe that doesn't always push the same way.
Right, so David Hasselhoff as an example of a weird info box. I think, so we tend not to make the argument when we present this that we should just do it blindly and automatically. We've always suggested that this should be pushed kind of into the discussion pages first, so an editor can make a decision. Once we've seen sufficient evidence that an editor goes with our recommendation, we can start to do these things automatically. But there's also, remember, some temporal effect. So we know that we always see the German article being edited first, quickly, and then the English one moves to copy that just at a later time. So if we keep seeing these patterns over and over again, German first, then English, and they always follow, we can learn this pattern and do that automatically. So yeah, there's definitely different ways of doing that depending on the ordering, so English before German or German before English, and ways of working within the norms of the Wikipedia editors. The Germans, for example, again, are very strict in their structure, so we can't just blindly push new data in. It requires a certain kind of process.
But haven't that the problem of the social influence that you're just talking about? I mean, if you push the wrong data, isn't other people going to be influenced to just carry on that mistake?
Possibly, that could happen. We try and do a little bit of voting. So if both the Germans and the French and the English speakers all say the same thing, then maybe it should get moved to Spanish. That is possible. So I suspect that already happens right now, that misinformation is copied back and forth. That happens. I don't know a good fix for it. I mean, other than making people aware of the provenance, so where this decision came from. This decision came from an automated algorithm which looked at these places, and this is what we decided to do. So it's important to kind of think about where the data came from and provide that to users. I think this is always the case with machine learning algorithms. You should always tell users kind of how you came up with whatever it is that you're telling them.
So you demonstrated that the social influence and the sort of the feedback channel is very important, and you showed some ways which you can actually actively sort of change it. But do you have any ideas how you could, I don't know, implement those, or how you model those in the real world? Like you had in the first project, you had all these examples. So what are the feedback channels there? Can you
Within the first one, so the
first
bloggers and the searchers.
Yeah,
and
so
that.
to me that would be the feedback channel, and then now you have all this other work. How does that sort of fit into that scheme? What can you do to help those situations and so forth?
That's a good question. I wouldn't make a strong argument that these two things are connected. One is that we're just trying to understand what's happening in the real world. It is true that the bloggers are influencing, everybody who searches. People read stuff on the blogs and then they go search. So there certainly is like a little bit of a causal relationship, but causality, as we know, is really hard to model in these systems. And so I don't have a good answer of like how to tease that out. The best I can do right now is correlation and look for classes of things that are predictive, or so either lead or lag other kinds of behaviors in terms of correlations. And from that, maybe through some qualitative analysis, make arguments about causality, but without logging kind of where everyone is going, what they're looking at, all their information consumption. It's really, really hard to say, they looked at this and then they did that. Sorry.
So that people will see the same thing differently.
Yes.
And you say
Yes. So it's so the question is about, I guess, the subjectivity of how one person sees data versus another. Right. So there's no absolute correct or wrong. We've thought about it. We haven't done anything in that area. I think that's a really interesting thing to look at, in which there's no objectively correct. I mean, there's never any objective correct answer, but in science. But there's slight variations, and in situations where there's a lot of inference that could be made, I think that's a lot of subjective kind of reasoning that could be made. I think that's an interesting problem to study, but we haven't done anything there. Yep.
Taking that idea of subjectivity and discussing the Wikipedia entries,
Mm-hmm.
there are certain types of topics that I think would be subject to very different opinions. So
Right.
I think that the German entry on George Bush would be different from the American entry, and so it's what kind of does the amount of content on a page override other perspectives as more important or more informative, such as the
Right.
Bonio.
Right. So yeah. So this has been Darren Gergel at Northwestern has made a similar argument about this, and I think it's perfectly reasonable to think this way, that we don't want to go in and basically stomp on some cultural perspective. I would never suggest doing that, but I think there's ways of informing another community and making that data available. So I think in many situations it's making that data available through things like the discussion mechanism, where an editor can make some decision about whether to include it or not, rather than automatically overriding or filling in missing holes in the system. An info box may be just as defined in the data that was selectively not present. So that could have been a decision made by the editor. They don't want specific pieces of data in the system. And it's not that they just didn't know the answer or whatever. They just decided that this was inappropriate, an inappropriate key and value pair to have, given whatever reasons they have. And so it's important to recognize that those holes should not be filled in. Observing that, if I fill it in and the editor comes in and automatically deletes it, having done that once or twice or 3 times, I can then tell my algorithm, don't do that anymore. So we can learn from the behavior of the editors to figure out which things are not appropriate. And it's not perfect, and some ways of getting around that are putting things more in the limbo state of the discussion rather than just automatically, throwing data into the Wikipedia article and
Well, I'm wondering, is there a hierarchy for types of information? So, that you've established. So, location information, like the destination that you mentioned, would that be more, and then versus like, if you visit Point du Hoc in France, which is a place that's been bombed out by Nazi bombs and stuff like that. Would there be locations are even sensitive, but from the travel perspective versus the historical perspective, and then not only that, but then the cultural perspectives within countries.
Sure. Yeah, and we haven't looked at it that much. I think there are examples of this. I do wonder how much of those are pathological. Like I can find specific instances that make this kind of thing not attractive. But the question is it in general helpful or in general inappropriate? And I would hope that it in general is helpful and could be heuristically at least modified so that it's acting in some appropriate way. But I don't know. I'm not. Yes, I'm aware of this kind of response, and I think it's important. I really do. There's things like time zones, things like pieces of countries that are disputed. Different perspectives are clearly important to recognize and not override.
So thank you for the lovely talk. I don't want to be too grim with this question, but it just really struck me that with your third study, your overall feeling about collaboration seemed very dismal. I
guess I shouldn't have ended with that one.
Well, but in the sense that if you take the assumptions which might have led you to pursue this research design in the first place, it seems like you're trying to warn us about these false signals, and yet this is sort of the tack taken by Encyclopedia Britannica against Wikipedia. Is this really the position you want to stand in?
So I didn't get to talk about it that much, but there are ways of dealing with these issues. I just think it's necessary to be realistic about the data that you're receiving from the masses. So these people who are untrained, or those are called zero intelligence agents or marginal intelligence agents, we have to understand what it is that they're providing and how to combine that data in a way that actually gets us the right answer. So I think there's computational ways of doing that. I just don't think that blindly, like, taking the average of everything that anybody else has said is going to give you the right thing. The Wikipedia, I mean, these are higher level functioning things. Like this particular example is really just a very simple psychological phenomenon. When we're talking about higher level reasoning, people who make the choice to edit a Wikipedia article either care about the article or they want to produce spam. Let's assume that they mostly care about the article and care about producing good content. So in those situations, like, that may cause them to think more deeply about what they should be putting in instead of just kind of guessing the proportional difference. So that higher level reasoning might work it in very different ways. So I don't think this invalidates the work that people are doing on Wikipedia or anything. I think it's certainly a reasonable direction to go. I think the Britannica argument's a little off in that way.
Well, the example that you made when you introduced it was with many eyes. So if we take your findings to heart, I mean, have you gone to many eyes and noticed this phenomenon?
Not so much this one in particular. We have, I mean, the many eyes is just to give you some context of the space that we're looking at. But you do see in many eyes, like if you search for quotes like, what you see is that where the person in creating a visualization is pointing to some visual aspect of the visualization, you do see that a lot. You see that quite often where people are telling the users, the subsequent users, to look at specific things. And given this kind of evidence, we know that that influences their perception. So that story that people tell about the visualization is likely to paint their interpretation of it. So I think we need to be aware that this happens, especially in the case of visualization, where there is that abstraction, where people are frequently unable to properly estimate probabilities, mistakes in the data, and so on. The statistical and visual literacy is awful in this country and in the world in general. So it's really easy to convince people to see things that aren't really there. And so we have to understand this, I think. Do I think there's ways around it? Yes, I think there are ways around this. I think it's just thinking about the problem and being aware of the problem that will lead to better designs that will solve it. I didn't mean to be that much of a downer about it. I actually like many eyes a lot. I just think that there are some designs that could be.
I mean, I would add to your comment that in any case, you should never take a result without checking it. Right?
Yes.
I mean, so if you put one of these up here, you might be getting good stuff, you might not be. But if you just assume that because it went through mechanical Turk, it's a wonderful answer because miracles happen, well, that's no better than trusting an expert either. So he's just saying, look, you have to think about where it came from. And there's some kinds of things that are going to work better in mechanical Turk and some kinds of things that won't.
Yep.
And we don't totally know which is which yet.
Yep, that's true.
So you showed people a standard histogram that you had offset by a standard deviation to show your
About,
classical sort of majority agreement and seeing what effect it had. Did you think about showing people a histogram with bimodal distribution or just flat distribution to indicate either no agreement at all or disagreement and seeing what effect that had?
No, that would be a really interesting thing to do. No, we should just showed Gaussians, and bimodal and just even distribution would be a really interesting thing to study. I'm curious if having that bimodal around the true answer, so peaks on either side, would either generate a bimodal response or some people would feel comfortable picking the thing in the middle because they knew that there was some debate over the number. Yeah, that would be a really cool thing to do.
Let's thank our speaker again.